Hello and welcome. Today, the lesson for the day is odds. Odds are the topic, and our learning goal for today is, after we've done the note and the homework, can I explain how odds work and apply them to real-world applications? We see odds every day. We talk about odds, or you hear them talked about, mostly in the gambling sense. So when we look at the odds definition, odds are simply another way to express our confidence about a certain outcome. So it's directly linked to probability, the topic we were just previously talking about. So it's just another form, another way for us to express our confidence in a particular event or outcome. So the notation. So the notation for odds, we usually use the letter A, and the formula is the probability of success divided by the probability of failure. So A prime. So again, P of A, PA, probability of success, and PA prime is the probability of failure. So it's a ratio or a comparison between success and failure. And more often, when we look at how it's written, it's more commonly written as the number of ways success could happen as a ratio of the number of ways failure can occur. So NA to NA prime. So for example, there might be 2-to-1 odds on a horse winning a race. For anyone in here that has ever played, or I guess in your case, anyone who's ever watched an adult person over 18 play any of the games involving the sports, sports line and so on and so forth, you'll see 3-to-1 odds, 1-to-5 odds in sports, which then talks directly to payouts. So these are all used to determine payouts. So that's where odds are used most often. And if anyone watches or follows the online poker, or watches the poker that appears on sports desks from time to time, they're also using odds as well when it comes to determining the success of a hand. So it's application. So our first example, the probability of a severe snowstorm for Windsor in January is 0.4 or 40%. So what we are given here is the probability of success, or a snowstorm. So I'll go snowstorm, and you can express it as a decimal, as a percent. It doesn't really matter. It's whichever one you're more comfortable with. So that's the probability of a snowstorm. Determine the odds. So to answer the question, what are the odds in favor of Windsor having a severe snowstorm in January? So you have to remember the difference between success and failure in order to answer this question. Success is what we're looking for. So in this case, our criteria for success is a severe snowstorm for Windsor in January. So it's actually the snowstorm. So failure here is actually no snowstorm. And you need to remember also from an earlier note that the probability of success plus the probability of failure has to equal 1 or 100%. You can't have a sum greater than 1 or 100% in terms of probability. So that would mean that to answer A, in favor of Windsor having a severe snowstorm, so success goes first. So I'll do all the steps here. So we are looking at, in this case, the probability of A compared to the probability of A prime. So the result would be 0.4 to 0.6. Now when you look at the answer in the textbook, they probably simplify it. They'll likely write it, first of all, without decimals, so a 4 to 6, and then they'll reduce the ratio. It's like reducing a fraction to lowest terms. All right, and for the proper notation. So if in the back of the textbook they have 0.4 to 0.6, you're absolutely correct, but they're more likely to have 2 to 3 odds on the probability of having a snowstorm in January. All right, and then the accompanying, don't forget your therefore statement afterwards. B part then. What are the odds against Windsor having a severe thunderstorm? Well, or snowstorm, sorry. Odds against just means that we lead with the negative or the opposite, so it's just PA prime to PA. We've already done all the calculations. So it's just a 3 to 2. So the odds are 3 to 2 against a snowstorm, or 2 to 3 for a snowstorm. So it's the exact same answer, except in reverse order. And the key here that you have to be careful of, in favor or odds against. So those are the two phrases. So I'll just make a note here. So in favor is always PA to PA prime, and against is PA prime to PA. And the way you calculate your PA and your PA prime is exactly what you were doing in the previous note. So the final example, the odds in favor of Raul hitting a home run is determined to be 2 to 7. So before I go any further, I just want to clarify what that means. So I see the words odds in favor. So that tells me that the odds will be given to me in the form of PA to PA prime. And notice my ability to draw P's decreases as I go through the note. And they have told us that it's 2 to 7. So that's in favor of hitting a home run. What is the probability that Raul will hit a home run? So the probability of a home run is equal to the number of ways Raul can be successful divided by the total number of outcomes. So with this, the information that's provided, we know number of ways he can be successful, and we know the number of ways he can fail. So when you answer this question, how many ways can he be successful? Well, he can be successful 2 ways. So we know that the numerator will be 2. But remember, the definition of probability is number of successes over the total number of outcomes. Total number of outcomes, NS. This over here is not your NS. It's not your total number of outcomes. Our total number of outcomes are actually successes and failures, so your N of S. So your N of S turns out to be 2 successes and 7 failures. So really the probability he hits a home run is 2/9, or as a decimal, 2 divided by 9 is about 22%. So there's a 22 or 0.22 chance he hits a home run. So you got to be careful with odds. Odds are straightforward. However, when you go back and forth between probability and odds, there is a little bit of a conversion there. So probability of hitting a home run is 2/9. All right, there's the assigned homework. Good luck, and if you have any questions with the homework, please let me know so I can clear them up.